Homework 10, Quadratic Functions, Video 2. In the previous video, we talked about how we're going to sketch the graphs of quadratic functions by locating their vertex and also by locating their intercepts. There's also another feature of a quadratic function called, or a parabola, called an axis of symmetry. Essentially, it's just the line that cuts the parabola in half. So when we find the vertex, we can also find the axis of symmetry, as I'll show you here in just a moment. You might recognize both of these functions from the first video, one in general form, one in standard form, but both are asking the same question. How do you find the vertex? Well, let's see. Let's start with this general form, which is find the vertex of f of x equals x squared minus 7x plus 10. There is a formula for calculating the vertex in general form, and it goes something like this. The vertex of f of x equals ax squared plus bx plus c. So if a quadratic function in general form is, well, first off, it's an ordered pair because it's a point on a graph, so it has an x coordinate and a y coordinate. And there's a formula for each. The formula for the x coordinate is a fraction. On the top of the fraction, you take the middle number, which is b, and you put a negative in front of it. And on the bottom of the fraction, you take the first number, which is a, and you put a 2 in front of it. So negative b over 2a. Now, just a little FYI, if you remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. The formula for the x-coordinate of the vertex of a function in general form is actually embedded in this formula, right there, negative b over 2a. And it's not a coincidence. If, let's say if we have more time, that I have all the time I want in these videos, we could actually derive that this is the x-coordinate of the vertex, but let's just take it for granted. So we calculate this and we figure out the x-coordinate of the vertex. There is a formula for the y-coordinate of the vertex based on a, b, and c, but think about it. This is a function. If you put an x value into a function, it will give you the y value that's associated with it. Negative b over 2a represents the x-coordinate of the vertex. So to find the y-coordinate, we could just take our function and insert whatever negative b over 2a equals. In practice, this will be a number, not an expression, once we figure out the number here. So let's find the vertex of f of x equals x squared minus 7x plus 10. The first thing we need to do is to find the x-coordinate, and the x-coordinate of the vertex is negative b over 2a. In this function, the b is the negative 7. It's always the coefficient of the x. So we're going to take the negative of negative 7. That will become positive. And in the bottom, we do 2 times the a, which represents the coefficient of the x squared. A is 1. So we have 7 on top, 2 on bottom, and that fraction won't reduce. We could turn it to a decimal, but I'm going to drag along the fraction because I'm not scared of fractions, and frankly, you shouldn't be scared of fractions by now. So we know that our answer is going to be 7/2 comma something, about 3.5 if you will. To find the y-coordinate, we just have to take the x-coordinate and insert it into the function. At this point, you're probably screaming, just let me use the decimal, but I promise you, you can handle fractions. We square the x, so 7/2 squared, minus 7 times the fraction. So minus 7 times 7/2 plus 10. Let's work these out and then worry about a common denominator. When you square a fraction, you square both sides. So 7 squared is 49 on top, 2 squared is 4 on the bottom, minus. For 7 times 7/2, the rule for multiplying fractions is multiply numerators and multiply denominators. The 7 in front is currently not a fraction, but I can write it over 1 to make it a fraction. And now just multiply the tops and the bottoms. 7 times 7 is 49 on the top. On the bottom, 1 times 2 is 2. And then we have plus 10. Now to put all this together, we just got to remember the rule for adding and subtracting fractions, common denominators. The 10's not currently a fraction, but I can make it a fraction by putting it over 1. And now look at the denominators, 1, 2, and 4. The least common denominator is 4. Or in other words, I can turn every denominator into 4 by multiplying wisely, by a well-chosen number. The first denominator is already 4, so I don't need to mess with it. The second denominator is 2. To make it a 4, I would have to multiply it by 2. But you can't multiply the bottom of a fraction by a number unless you multiply the top by the same number. So the top's going to get multiplied by 2. 49 times 2 is 98, so I'll just cross that out and write 98. And on the third fraction, the 10 over 1, I can turn the 1 into a 4 by multiplying it by 4, but then I have to multiply the top by 4. So the top of the fraction becomes 10 times 4, which is 40. And now I can put it all together. I guess I should change all of these denominators to 4. That's why I set them up that way. But now that all the denominators match, my common denominator is going to remain 4. And on the top, I just have to do 49 minus 98 plus 40. 49 minus 98 plus 40. And if you do the math, looks like you're going to get negative 9. So negative 9/4 is the y-coordinate of the vertex. Had you substituted 3.5 for the x instead of 7/2, you should have gotten negative 2.25. I'm going to pause the video and then start another one to show you how to find the vertex of standard form. And by the way, finding the vertex of general form is not always this crazy. The only reason it was in this case is that when we calculated the x-coordinate of the vertex, we got a fraction. There are times where this is a whole number and substituting into the function is a lot easier.